Hello, AP Stat students. Today we will be doing a two-sample confidence interval in a difference in means. Suppose we want to compare the means of some quantitative variable for the individuals in population 1 and population 2. The ideal strategy is to take a separate random sample from each population and compare the sample means. So x1 bar and x2 bar. We compare the populations by doing inference about the difference between the parameters. The statistic that estimates this difference is the difference between the sample means. Okay, if we start with the z statistic, we can modify it to replace sigma with the standard deviation from the samples. The result is the standard error, so the estimated standard deviation of the difference in sample means. So the standard error now becomes the following. So all I'm going to do is replace the numerator with the sample standard deviation. So sample standard deviation of 1 divided by the sample size of the first sample, and then this plus the sample standard deviation of the second squared over the sample size, the second sample size, and it's squared because you add the variances. So when we standardize the estimate now, the result is the two-sample t statistic. So the two-sample t statistic, so t is equal to, so you have sample mean of the first minus sample mean of the second minus the null, which would be 0, divided by the standard error, so the formula that we just wrote. This two-sample t statistic has approximately a t distribution. It does not have exactly a t distribution, even if the populations are both exactly normal. However, the approximation is very accurate. There are two options for using the two-sample t procedures. The two options are exactly the same except for the degrees of freedom used for t critical values and p-values. So if you're going to use technology, the graphing calculator will do this for you. So use the t distribution with degrees of freedom calculated from the data by a somewhat messy formula. The degrees of freedom may not be a whole number, and the reason why it might not be a whole number is because you have this fraction I'll show you. And you don't have to use this formula. You should never use it by hand. So here's this formula. So the degrees of freedom is equal to, in the numerator, you have this. So S1 squared 2 over N1 plus S2 squared over N2 squared, that's the numerator, all over, that's 1 over sample size of 1 minus 1 times S1 squared over N1 squared. It's obviously it's ugly. And you don't even have to really write this down. But I just wanted to show you if you ever end up taking another statistics class in the future. Oops. But I'm just going to point this out later when we actually do use technology in our example. Okay. So that'll give you the degrees of freedom. Well, you do not want to calculate by hand, obviously. And there is one important piece of information here. This only applies when the sample size is greater, both sample sizes are greater than or equal to 5. This is the better option, the conservative option. Use the t distribution with degrees of freedom equal to the smaller. Before, we just took the degrees of freedom is equal to the sample size minus 1. Well, now you have two samples to be concerned with. So what you do is you take the smaller of the two. So if the sample size of one is, say, 40 and the other is 30, you would take the 30 and subtract 1. You would have the 29 degrees of freedom. So you take the degrees of freedom is going to be equal to the smaller of either of those two. With this option, the resulting confidence interval has a margin of error as large as or larger than is needed for the desired confidence level. The significance test using this option gives a p-value equal to or greater than the true p-value. As the sample size increases, confidence levels and p-values from this option become more accurate. Okay, let's do an example. So for this particular one, we are going to, this is what the four-step process would look like. So state portion, estimate the difference of whatever, whatever at whatever confidence. Use a two sample this time, t interval for means if the conditions are met. So the random condition, the data produced by a random sample of size n1 from population 1 and a random sample of size n2 from a population 2 or by two groups of size n1 and N2. Normal condition, if each sample is large enough, so the first one greater than or equal to 30, and the second one greater than or equal to 30, then the sampling distribution will be approximately normal. If the sample is not large enough, then graph both samples to check for skewness or outliers. For the independence condition, both the samples or groups themselves and the observations in each sample or group are independent or meet the 10% condition. If conditions are met, perform calculations. So we are going to compute sample mean of the first sample and the sample mean of the second sample, and then their differences. You would compute the standard deviation of the first sample and the second one. And remember, you're going to use your one variable statistics unless they're given to you. Then compute T star using the inverse T, and then compute the interval. And so your formula for your interval is the difference in the sample means. So that's your statistic plus or minus the T star, which you get by using your inverse T, times the standard error. And combined, remember, the T star times the standard error gives you your margin of error. So S1 squared over N1. And this is on your formula sheet, so you don't have to memorize it. You just need to know how to calculate a T star. Okay, here we go. And then finally, interpret the results of your test in the context of the problem. So we are 95% confident that the interval formula, yada, 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 and so on. Okay, so we'll do one example. Do plastic bags from Target or plastic bags from cars hold more weight? A group of AP statistics students decided to investigate by filling a random sample of 5 bags from each store with common grocery items until the bags ripped. Then they weighed the contents of items in each bag to determine its capacity. Here are their results in grams. So Target, you have your 5 bags. They're the weights in grams, and cars. So what I did is I put Target in list 1 and cars in list 2. Construct and interpret a 99% confidence interval for the difference in mean capacity of plastic grocery bags from Target and cars. So in our state portion, estimate the difference in the mean capacity of plastic grocery bags from Target and cars with 99% confidence. So I am going to choose Target minus cars. Yeah. We will use a two sample t interval for means if the conditions are met. And so let's look at our conditions. Random, it is a simple random sample of 5 bags from Target and 5 bags from Cars. Normal condition, well, we know 5 is not greater than or equal to 30, so we have to graph. And so I entered the data in my calculator, and this is what the graph looks like. And you must show your graphs. So the graph, this is from Target. So specify which one is which. And this is what it looked like. So it looked pretty good. This one may have been a concern. Well, it was a concern to me. So I went ahead and did a modified box plot, which shows our outliers again. And it was fine. There were no outliers. It was perfectly fine. And for Cars, it looked like this. So Cars. And again, it looked pretty decent, but this again was a concern to me. So modified box plot revealed that both were okay. So there were no outliers or strong skewness for either sample. Right. So approximately normal. All right. And finally, independent. Target bags should not affect Cars bags. Meaning it's reasonable to assume that the strength of one bag doesn't affect the other. All right, in our do portion, so did my one variable stats here. I got the sample mean. Oh, I guess I should specify which one, but here. So this one is Target, and this one is Cars. Okay. So Target is 12,825.8 grams, and its sample standard deviation is 1912.5. Cars, 9,234 grams. Its sample standard deviation is 1,474.2 grams. Okay, and then I would do an inverse T. So my area, since it's 99%, 1% left over. So that's 0.05 or 0.5%, which is 0.005. And our degrees of freedom, since both bags, there's 5 in each one, it's going to be 4. Okay, so that gives me a T star of 4.6. Right, now we are ready to go ahead and put all of our numbers into our formula. So we have at this point 12,825.8 minus 9,234 plus or minus T star times the standard error. So we have 1912.5 squared over 5 plus the standard deviation of the second, which is 1474.2 squared divided by 5. All right. That gives me right here, we have 3,591.8 plus or minus 4.6. I did all that stuff under the square root and then took the square root of it, and I got 1079.9. And that then gives me 3591.8 plus or minus 4967.5, yielding me an interval lower bound negative 1375.7 and upper bound 8559.3. So we are 99% confident that the interval from negative 1375.7 to 8559.3 captures the actual difference in the mean capacity of target bags and cars bags. And then we will look at a follow-up question, say, so since 0 is in the interval, it is possible there is no difference in the two bags. So since 0 is in the interval, it is possible that there is no difference in the two bags. Right. You can also do a 2-sample t interval on the calculator. And what you do is you go to stats and then you go arrow over to tests. You choose the 2-sample t interval. And then you choose data or stats. I mean, you've already calculated. If you want to, just use your data because you already have them in a list. Choose data. Enter your appropriate information on the prompts. And don't ever use pool data when working with means. That's only for proportions, and they will give you that option. And then it's going to give you the interval. And the interval it's going to give you, if you try this, is negative 100.9 to 7,284.5. Why is it so different? Because it uses a degrees of freedom that is using that complicated formula and gives you the degrees of freedom as 7.513. However, our main conclusion is 0 is still in the interval. So the answer just is more accurate. The interval is more accurate. It is preferred to use a calculator on this interval, but honestly, you would not be counted wrong either way, whatever method you choose to do this question. And those are your notes for today. Have a great day, AP Stat students.